Anyway, yeah, 8:02. Let's get it rolling. So welcome everybody. The February 4th edition of the Switch Open Meetings. I don't have a script in front of me because Ted and I are sort of tag teaming this. Ted has to step out for a little sec, and we'll be back. But Ted, do you want to do the acknowledgements right now, and then I'll do introductions.
Thanks, David. I last minute had to just do a quick errand. I'll be back, but I want to welcome everybody to our open meeting in February. As usual, we start off with introductions, and I will first of all let people know that we have a number of membership renewals, and I want to say thank you very much to all the people who are members and support Switch in that way. So we have some renewing members and new members. On the corporate level, we have Cunningham, Swan, Cardy, Little, and Bonham LLP. Thank you very much. They've been a longtime supporter, as well as Kedco, which was around at the founding of Switch 20 years ago. We have Wintergreen Studios, a small non-for-profit that is renewed. Quantum Renewable Energy, small business, longtime member and participant in this field. We have individuals, Vivek Gupta, Rosamund Hyde, Steve Isco, Chad Joshi, Darko Matovich, Kim McCauley, Carol McKay, and we have Thomas Sears, a student. So thank you all very much for being members and for supporting Switch. And if you're not already a member, please consider being a member. You can join just by going to our website, switchontario.ca. And I'll just turn it over to David now to do the round of introductions before we get to our speaker, Abhishek Awasthi, who's going to talk about power electronics and renewable energy.
Yeah. All right. Thank you, Ted. Usually the person who finds the speaker gets to be the host because they've developed a relationship, which is why Ted was going to do double duty today on being the technical guru and doing the hosting. So I'm stepping in the short term. Abhishek, welcome. We'll do a little bit more introduction to you after we've done everybody else and before you jump into your presentation. So, Ted, one last thing. As far as sharing sharing Abhishek's presentation, anything you need to do, or is that
I think he's going to be sharing from his computer.
Okay,
but, I'm just on the phone with him now, and I'll sort this out before I
just to make sure that the tech works.
That's right.
All right, let's get going around the table. Let's start with Harriet.
Hi, Harriet Waterman, retired from the National Research Council IRAP program, a longtime member and board member of Switch, previous board member of Switch, I should clarify, and got the panels, the EV, and all that kind of stuff. How's that, David?
Oh, marvelous. Preaching to the converted. Let's go to Brant Pepley.
Wow, I get a second. By the way, I'm renewing my membership too. Ted, I don't know if that notice came through, but I filled out the form, but apparently I have to be approved to be renewed now because it's been so long.
Oh, well.
Anyway.
Take it up with Rosie.
Yeah. Anyways, so my name is Brad Pepley. I'm a professor at Queen's University, and I'm the director of the Collaborative Masters of Applied Sustainability program, and long history in hydrogen and fuel cells. And the other thing I'd like to confess to, and one of the reasons I really felt I should renew my membership is for the Collaborative Master of Applied Sustainability, there's a seminar series. So I'm looking for good presentations to include as part of my seminar series, and the Switch meetings are perfect for it. So there's a number of people attending this morning. I think there should be 3 who will be here as part of the seminar series for the Collaborative Masters of Applied Sustainability. So that's what I have to say.
Hey, Ted. Sorry. we're on 2 different channels here. Darko.
Okay.
Oh, sorry, Ted. Yeah.
No, Abhishek's microphone we can't get it to work, and so we're wondering if you can hold up your phone to the microphone when it's time for him to speak.
Oh, my microphone?
Yeah, or you know what? I'll just wait till I get back. I'll be back in 10 minutes. Sorry.
Yeah, well, we'll,
Yeah.
we'll get through this, and maybe we'll do some sector news just to get things through. Well, the joys of technology. I see Helen has come back to her seat. Would you like to introduce yourself? Oh, you seem to be frozen there.
You
Oh
have
my
to
goodness.
unmute. You have to unmute, Helen.
Yeah.
Unmute.
Bottom left. Yeah.
There you go. Does that work?
Perfect.
Better?
We hear you loud and
Alright.
clear.
Okay, thank you. Talk about me. All right, the operative word here is retired. I have to keep telling myself that. Yes, so anyway, I remain quite interested in low energy building, in all the same environmental concerns I've ever been interested in. And here I am, still find value in these meetings and in this membership, and always look forward to getting together.
Thank you. All right, Darko. Oh, I'm not hearing you either, Darko. Nope.
Okay, how about now?
No, perfect. Yes.
Okay, this goes.
one of those days, eh?
Yes. Okay. Morning, everybody. Dr. Matovic, vice chair of the current board, and also retired from Queens. With Brent Pepley, I'm just gonna, after this meeting, give a lecture to his class on biomass sustainability. That's one of the aspects of renewable energy that I was involved with, combustion and so on. Long-time member, and looking forward, continue.
All righty. Let's move on to Rosie.
Hi, I'm Rosie Hyde. I'm the treasurer currently for this present board of Switch, and a longtime fan of renewable energy with several pieces of renewable energy around my residence. Thanks, David.
Thank you. And Eric Collins.
Good morning, everyone. I own CDK Solar Solutions. We're a relatively new company to the area, soon to be a Switch member. And we mainly do off-grid and grid-connected systems.
Well, welcome, and hope it goes well.
Thank you.
All right, next, Kathy Ireland.
Good morning, everyone. I'm representing Spark at these meetings, but personally super interested to learn from so many of you. Really appreciate having the opportunity to participate. And with the initiative that I'm working on with Spark, it's the Eastern Ontario Innovation Corridor Initiative. We're working to expand opportunities for sharing and for collaborating and spreading good news when good things happen, and resolving challenges. So I think if you think of something that makes sense, and also we've got networks, we're establishing networks across the corridor. So if there's need or things to collaborate on, feel free to contact me.
Yeah, and certainly if you reach out through Switch, we will get you in touch with Kathy. Just a side note, I'm doing an interview this afternoon on Switch for a publication that Spark will be putting out, I think in March, it was said. Mm-hmm. So we get to promote what we're all about, and thank you, Spark, for spreading the word. So that's great.
Yeah, no, that's great. Yeah, and that's the other thing, besides vehicles of platforms where we invite people to with, as a result of COVID, normally we have in-person meetings, but we also have the Spark magazine, and we're profiling businesses across the corridor on different themes as they come up. So we're always reaching out to this network, for supports and things like that too. So yeah, that's good. I didn't know
All
about
right.
the article, so that's great.
Yeah, no, we're happy to contribute. Let's go to Ian Arthur.
Good morning, everyone. I'm Ian Arthur, board member for Switch, MPP for a very short time longer, and now one of the founding members of a company called Nidus 3D, which is going to do 3D construction printing in Ontario and across Canada. And we actually just confirmed our first build. So
All right.
we're starting in April.
And a future presenter.
Future presenter, yes.
We've already figured that one.
Congratulations, Ian.
Thanks.
We'll move on to Vivek Gupta. Oh, you're muted. You're on mute.
Good morning, everyone. My
go.
name is Vivek Gupta. I'm the president of Solar Energy Tree Intuitive Solar PVT Limited. And this company has developed a new way to collect solar energy in an efficient and economical manner. So we call it a solar energy tree. I would be glad to make a presentation. I did make one presentation, but I would be glad to make another one. And I'm looking forward to today's presentation.
Perfect. Thank you. Carol McKay, if you're.
I'm here as an interested observer. I'm retired. I have a particular interest in hydrogen, and that's about all I have to say.
Well, thank you, Carol. Colin Beckingham. Are you there, Colin? I'm not seeing a bit. No. Anyway, and just to interject, the reason we do this is that you never know where those cross connections are going to happen. You know, someone needs a service that someone else is providing. Someone needs some information that someone else has. So that's why we certainly go around the table every meeting just to make sure that the connections are being made. Kit Nguyen.
Is that me? Good morning, everyone. My name is Keith. I'm one of the master students at Queen's University. And I take a program called Collaborative Master in Sustainability. And I'm one of the students of Professor Brant Pepley.
Okay, well, welcome. Thank you. Where am I going? I see Herman.
Hi, everyone. My name is Herman. I am a Queen's alumna. Even though I'm working in the financial services industry at the moment, I am just particularly interested about renewable energy resources. I also know Abhishek because he and I were in the same batch when we were doing masters together. So I'm just here to learn more about the same.
Well, marvelous. And you know what? The financial sector is going to be what drives this. You know, making sure that the numbers add up and making sure that the finances are available for all the techie people to do their thing. So thank you. Karina.
Hello, I am backlit. Good morning. I'm here as basically an interested observer. I'm interested in how having some of the like integrated technologies or EV cars connected to the grid might support that, especially with the maintenance coming up on some of our reactors, and if that could maybe offset us having to use the natural gas peaker plants as full-time options.
Interesting concept, interesting interest. Thank you. Satara Sadarova.
Good morning, everyone. My name is Sitara. I'm a student of Queen's University, Master of Engineering in the Electrical and Computer Department. And I'm also taking the collaboration with Applied Sustainability.
All right, well, welcome, thank you. Kieri.
Good morning, everyone. I am Kiari Gonibulama. I am professor at RMC, also affiliated with Queen's University. I teach and do research in energy in general, renewable also as well. Okay, nice to have you.
Thank you. Ken Dancer, sorry.
Hi, Ken Dancer, Carico Development. We're a builder and developer, and I am saddling myself with some research on how electricity is going to work in our future developments of various sizes, which is proving not an easy task.
Well, I'd say you've come to one of the right places. So we, certainly reach out if you need more connections or other.
And also maybe a presentation, David, on some of the issues in his industry. That would be most helpful that he could pass along.
That is very true, because then those that can supply solutions will come to you. And I don't know what just happened, but my tiles just doubled, so we have a few more introductions to get through. Next, I see Abdul.
Hello, hi, good morning, everyone. This is Abdul Chandi from Kingston Economic Development Office. I'm the Investment Manager for Sustainable Manufacturing. Pleasure to be with you all.
Thank you very much. Tom Brackenberry.
Hi, I'm Tom Brackenbury. I'm an electrical distribution engineer with Utilities Kingston, and I'm attending for interest.
Thank you very much, Tom. I see Andrew Backus.
Morning, everyone. Andrew Backus with City of Brampton and former board member with Switch.
Perfect. Let me just, I'm getting some messages in the way here. I'm just trying to figure out who I might have missed. I see an Alex Sukamonian. Apologies on the name if I'm getting it wrong.
No, it's right. It's right. Hi, I'm Alex. I'm from Queen's University.
Thank you for joining. Still trying to get the. I think I've got everybody. Oh,
Gavin.
Hello, Gavin. Sorry, you popped into the middle of the tile set.
I'm Gavin Hutchison. I'm with a board member at 350 Kingston.
Good morning. Thank you for joining.
And John Beard.
Is John? Am I missing anybody else? Raise your hand, just jump in. I think we're good. So my name is David Hindman. I'm the current president and board chair. Oh, there's John. Okay, John, sorry.
Good morning. I'm just having some technical difficulties this morning. I think it's all part of winter. Anyways, I'm representing the social housing project in Belleville for seniors called Emmanuel Residences. Good morning, all.
Morning. Thank you, John. I think, unless someone else jumps out up at me, I think that's it. Ted, you are back. I will pass it back to you. You indicated that Abhishek's audio may be working, so we can. Abhishek, do you want to give it a try? Just make sure.
Yes. Can you hear me now?
You bet. That's
Oh
awesome.
my.
Very good.
Thank you.
All right, Ted, back to you.
Okay, thank you, David, and sorry very much for the my absence. It's this last minute thing. So welcome again. Our speaker today is a PhD student at Queen's University, Abhishek Awasthi. He's in the power electronics group of Praveen Jain, and he works on power electronics as something that enables the integration of renewable energy, like solar PV, into the power grid. He is from India, and he received a undergraduate degree in India and received a master's degree here at Queen's, and he's currently working towards his PhD in the electrical and computer engineering department at Queen's University. We're very happy to have Abhishek here today. Abhishek, do you want to I think you said your microphone is probably working now, and we'll let you unmute.
That's correct. Yeah.
Okay, great. It sounds good. So sorry, everybody, for the bit of a scramble there when the microphone wasn't working. And I appreciate your patience this morning. So Abhishek, I'll just let you take it away.
All right. Thank you. Thank you so much, Ted. Thank you so much, everyone else, for bearing with me. I don't know why technology backfired on me. I'm the one who's usually propagating tech, but today it backfired on me. Okay, so you can see my screen, right? Perfect. All right. Yeah, so during this talk, like when I was preparing this talk, I had I did not have a clear idea of what I should achieve, because this field as a whole is so big. And I'll try my best to summarize what I think are the key points and the key takeaways and the future potential of this tech, and hopefully with the experience I see on this call, I'm pretty sure I'll walk away with a better perspective and more ideas to work towards. So I'll begin. So this is how the outline will be. First, I'm gonna deep dive into power electronics, the tech. What is the past? Where are we right now? And how does it look in the future? Then I'll try to explain how this tech is behind supporting higher integration, higher penetration of renewable energy sources. My focus will be specifically on PV renewables. Going down, we'll start discussing a bit about grid connected or grid following and grid forming in PV inverters, the latter of which is a newer technology. I'll try to summarize the issues that we in academia are facing and potential solutions which we think should work, but who's to say? Then I'll venture towards the potential decentralized grid, how the future grid might look like, and end up with challenges and opportunities and more questions. So yeah, power electronics tech. So this technology is a very multidisciplinary technology, and it combines so many fields. You need to have knowledge about machines theory, circuit theory, control theory, power system, electromagnetics, solid state physics, simulation tools, electronics. So it's like a perfect blend of all the interesting fields. And the idea behind this is that you are combining power and electronics. Electronics usually refers to lower voltages operation, but higher frequencies, whereas power usually refers to like high power, high voltages. So we are trying to combine these two together. And this field is old. Work started way back in the 50s, but it has progressed significantly. So this basically allows for efficient power generation, power transmission, power distribution, and power control. So every step, right from the generation to control and even consumption, even most of our loads that we have in our houses are dominated or have some sort of power electronic circuitry in them. So it's in every instrument that we are using, your laptops, your chargers, you'll find power electronics there. So this is how a general schematic, I should say, would look like. What we are facing with now is we have some sort of power source that might be a big generator in a power plant, that might be any intermittent source like PV, wind turbines, fuel cells, batteries. So the idea is that you have a certain source that you have to make the best use of, and you have to power and condition that power in a way that is usable. So the idea is that, okay, if we need to change a state of a power, you need to have intelligent control, you need to have good microprocessors, and you need to know what you want out of your system. The essential idea is we are aiming for the 3 C's. We are aiming to convert this power, whatever the power might be in any form. We have to control this power because depending on what the loads are, you need to make sure that you have efficient control of this power, and then you need to condition it. Obviously, standards in different countries impose certain requirements that has to be met by the power in terms of its quality. So you need to make sure that the interfacing power electronic tech is able to meet those demands so that your product can be certified. So just a basic deep dive again. You can have different forms of energy. You can have it from AC if you want, a DC. This is usually what your chargers are. If you look at your laptop battery chargers, it takes in AC from the plug, and it powers up the 12 volt, 5 volt, or core, the microprocessor core voltage, basically, the low voltage. Then you have DC to DC converters. You can have DC to AC converters, which are usually known as inverters, and then you have AC to AC as well. So this tech is very silicon intensive, which is basically the backbone, and I'll talk a bit about that. It's basically the backbone of this tech because you are basically trying to shape this power through switching, and you're using switches which are made out of silicon. And the whole idea was propagated way back in the 50s. The first FET, which is the field effect transistor, was developed in Bell Labs, but the patent for this was developed and published way back in the 20s. So there's a nice bit of history going on around there. So if you look at the timeline and the future potential of these backbone, we started off with the FET, which led to the development of these thyristors. These were the go-to devices during the 70s and 80s. My supervisor, when he was doing his PhD, he was only accustomed to thyristors, even though MOSFETs were there, but they were not commercially viable. So you have like plenty of these devices that each of them had their own certain characteristics. And the idea is that you want to control huge amounts of power through a low voltage circuitry. You don't want your microprocessors. Basically, it's going to be your microprocessors who are going to control each of these devices. And you want to make sure that you're able to use these lower voltages to enable high power going through these devices. MOSFET, which were conceptualized back in the 76, are still the go-to devices. And we are going towards what is now known as the wide bandgap tech. I'll talk more about that. So here's where we are in the scheme of the current power devices that we have. We have been able to see and commercially design up to 1 megahertz of converters. So the idea basically is that as you start increasing the switching frequencies, your converter starts becoming smaller and smaller and smaller. And this is something that we have seen throughout our life. At least back in India, we used to have a variable resistor sort of big box to control the fan speed. And now they are tiny, more electronic intensive. So we have reached pretty high transmission levels with silicon MOSFETs and IGBT modules, but the idea is to push the envelope. And where we are right now is you have two major wide bandgap technology, which are the SiC, which is the silicon carbide. This is usually suited more for higher voltage applications. And then you have GaN, which is gallium nitride on SiC. These are high electron mobility transistors. So the whole idea behind this is to increase the switching frequencies of these converters, of the tech that we are using. And if I were to explain it to you, put it even simply, think of it as you have two tubs and you have to transfer water from one tub, which is completely full, to a tub which is empty. You can take a big bucket and transfer it slowly, or you can take smaller and smaller and smaller buckets and transport that water faster. So that's what we're trying to do basically. We're trying to make that bucket small as possible, because that basically shrinks the entire device that you are going to be using to interface any renewable energy source to the grid, your home, off grid, whatever. So semiconductor devices are basically the backbone. And now we are venturing this tech, as I've told you before, is very diverse in its study. There are lots of fields working together to make that one end product. And it requires integration of other tech. You need to have idea about fluid dynamics, mechanical systems, because basically you are generating heat when you're processing this power. And a very important component is to make sure that you're able to manage this heat so that it doesn't affect the performance of your device. Your device doesn't get overheated. So you have cooling systems. The discrete devices, which I just talked about, MOSFETs, thyristors, GaN, they are a separate field of study. Then you have integrated power modules. As I said, the push is towards making it higher power density, achieving higher power density. And so what they're trying to do now is they're trying to integrate topologies. There are certain topologies, and they're trying to integrate it onto a single package so that you don't have these discrete components. Then you also need to be knowledgeable about magnetics, because those are an essential component of your device. DC link caps. There are so many studies going into the dielectric materials which you use for these caps, and so on and so forth. So you can see the study and the components of that are involved in making one device are venturing into so many different fields. And this is what is required if we actually want to interface these renewables, whatever renewables those might be, with the grid. So this is where we were, and this is just to give you a timeline of where we will be going eventually. India has set very ambitious targets in terms of solar. I believe they have set it at 20 or 30 gigawatts. Now they want to achieve that level of penetration in the next 2-3 years. And you have these devices which are used in so many different techs. Electric vehicles. This is the backbone of electric vehicles, making them faster, more efficient, and making sure that they are adopted faster. Renewables, which I'm going to talk about more. Data centers. The biggest push for this tech came back in the 80s and 90s when the space industry was booming. And so there was demand for making power supplies smaller and more efficient power supplies. And that is what my guide went into. He went and worked on the Canadian space station. So this is where it sort of got the push. And now we are venturing more into the automotive sector. So if you talk about PV, just as an example, we all know climate change is real, and it's very, very necessary to reduce these carbon emissions. So the debate is still on whether how green is renewable energy, and we can discuss that all day long. But definitely, we have seen studies in which even if you look at the whole product lifetime, right from manufacturing to recycling, the amount of carbon that is emitted during this one product setup of renewable energy is far less than producing it through conventional power sources. So this is how a usual PV renewable or renewable penetrated grid would look like. You have individual residential and commercial distributed generation, which should be within 5 to 500 kilowatts. Then you have community scale distributed generation. You can have this varying between 500 to 5 meg, and it enters the grid via distribution lines, goes to each house. And then you have a centralized utility scale generation. And this is what I'm going to talk about more, that how can we make this decentralized? How can we basically bring this all the way over here? So this is what we are aiming for right now, because even now we all know what happened with the Texas winter storm. Reports are coming in that this year they might face another winter storm. So it'll be interesting to see how their grid performs. And there was so much politics going on around, that you had too much renewable energy penetration. That's why the grid failed and whatnot. And there are problems. We have to accept that there are problems. They're not dispatchable. You can't simply turn them on. You have to have sun in order to produce PV, right? The next challenge is the power quality. If you have a power source which keeps shutting on and off, you have to make sure that you're able to supply constant power. You're able to maintain voltages. You're able to maintain those grid standards. You can't have a system made of PV and shut down completely. That will cause grid instability. So there are standards which I'll briefly discuss. You have small term and seasonal power fluctuations. We are seeing that with climate change, the duration of sun irradiance for a day. These things are changing. The seasonal patterns are changing. Storage, and this is one of the major aspects, the major reasoning why PV or any renewable energy source can be successful is storage. If you have excess energy, you store it in batteries. If you don't have that PV, it's intermittent, as we all know, then you use this storage to power up your homes and devices. Then again, there are protection issues. There are islanding issues, which I'll discuss in the next slide. Optimal placement. How do you decide what capacity of the plant should you install at a certain location? What factors are you considering? Do you have a model for this? How do you decide which grid is weak and which grid is strong? So optimal placement is another issue. We have to make sure that the setup of the plant guarantees the most that we can get out of it. So here is another issue that I was talking about. Since we have all these intermittent resources now with PV and wind, we need to make sure that our converter, the power electronic converter, can act as fast, right? And the issue with that is that you need to make sure that your control algorithms, whatever code that you have on these microprocessors, FPGAs, DSPs, they are fast, they are smart. And anti-islanding basically refers to if you don't have any grid, right? Then you ideally want your solar to stop producing power, to stop exporting power to the grid, because if there is no grid, if there's a serviceman coming in to fix it, this line is still charged, and that's a potential threat. So you need to recognize when the grid is not there. And this is just one of the many challenges and requirements that come from the standard that are there in many countries. Power converters, they should be fault resilient, they should be robust, and they should be reliable for a seamless PV renewable grid integration. We take power for granted. Every time we plug in our appliances to the socket, we expect the bulb to turn on, but it's such a complicated network, and it has taken so long for us to reach at this level of grid quality that it's just amazing. That's my opinion. And obviously, when we are going to transition to these PV renewable grid integration, higher PV renewable grid integration, there are going to be issues. we can't look everything and we can't see everything on a piece of papers, but we are trying to make sure that we don't run into those issues. So as I was saying, these interfacing converters need to have functionalities and be really smart, right? So, and you have standards for that. You have IEEE standard, you have the IEC standard, UL standard, California Rule 21. This is a very well-known standard that imposes certain restrictions on the type of power that you can deliver, volt, watt, frequency, watt. You shouldn't shut off your inverters if the grid voltage goes down for a certain amount of time, because if you have all the homes feeding power to the grid and all of them shut down at the same time, as I said before, you're looking at potential stability issues. So this is how now we are trying to come out. First, we started with the device level, then we went to the converter level. Now we're trying to look at it from a system level, that, okay, you have some sort of tech that you're using to interface these intermittent sources, and these are your requirements. You have a certain P and Q, which basically means active and reactive power, that you need to feed into the grid. And how much of this you feed will have to be decided. Now, this decision has to be communicated to these inverters, and these inverters they might be remote, where you don't have even good cellular data. So these are just certain challenges. We are trying to reach out to remote communities and make them go off the grid. But if you really want smart operation and smart operation, basically, then you need to ensure that you have certain requirements for that area that are met. The inverters, they need to be self-secure. They should be self-adapting, self-governing. So there's a lot of self, and that has to be obviously programmed into these inverters, which brings me to the next topic, which is the grid following and the grid forming mode. These inverters can operate in either of the two. Our understanding of whatever the power system stability is based on high penetration of high inertia traditional synchronous generators. The traditional power grid, you have high inertia, and when I say high inertia, it means it's a strong grid. You can't distort the voltage that you receive that easily, no matter how much load you put on that grid. The voltage is stable, and the system voltage and frequency in India, it's 50 hertz, here it's 60 hertz. It's set by this high inertial sources. So existing grid following or grid connected inverters, they have to track or follow this voltage and frequency. You can't have a connection of two different voltages and frequency. That's not possible. So these grid following inverters are still difficult to design, but they are simpler compared to the grid forming inverters. And as I've been saying before, digital microcontrollers, faster microcontrollers, higher clock speeds for these microcontrollers so that we can communicate more, do more faster is a necessity. We have had to take decisions for these inverters in microsecond level. Since we are increasing the switching frequency, the time response for these converters is in microsecond, and we are going towards the nanosecond domain. So it's necessary that whatever decisions we make through these microcontrollers are faster than the time response of the converters themselves. Which brings me to my next point. This is how the present or even some sort of a future grid might look like. You have tons of these high inertial sources, generators at different power generating plants. You have inverters, your inverters. You might have some distributed generation here, some solar here, wind here, all of that is there. And then you have tons of these power plants. You have homes, one or two might have PV, and this is it. It's still difficult, but the whole idea of this guy is to make sure that it follows the grid. The future will be more decentralized. You will have more inverters, you will have more intermittent resources. Each home will be, could be a grid itself. You have electric vehicles. They are being adopted at a very fast rate. Each home might have more solar adoption. You might have battery banks that might act as a power generation system. I know ABB did this project way back. They started off in 2010 or 2012. Big kilowatt, gigawatt hours capacity battery banks. They're still researching into it. But the whole idea is that these inverters, they form the grid. Instead of big generators, it's the inverters who are going to form the grid. So which brings me to, and I want to summarize it more clearly, you have the grid following and the grid forming inverters. They simply follow and synchronize to the grid. In this case, the grid forming inverters, they have to make their own grid. Each house or each community, wherever you want to dissect it, has to make their own grid. Obviously, if you have no voltage, then the inverter will lose this source and it will shut down. Whereas this is not the case with a grid forming inverter. Another potential application of grid forming inverter is maybe black starting. We know that whenever we have to open up or start after a blackdown, any power generating unit, we always start with a smaller power resource, and then we try scaling it up. So this could be one of those. You have a certain grid forming inverter, they turn up. Once this is communicated to the main power plant, then the main power plant could be turned on. So there's a lot of uncertainty still. It's a new field that we are venturing into. So PV inverter tech again is, we all know this. We have string inverters where you have these voltages connected in series. Then you have micro inverters, which is what we are working towards. And you have power optimizers, which you connect in tandem with the string inverters to get better efficiency from the solar panels. Because it's a very well-known fact that now your solar panels are going towards higher power. We started off with a 60 cell solar panel. We are at 72 cell solar panel, and we are going towards 144 half cell tech. So these panels are becoming more powerful. They're becoming more efficient. They're able to extract more power. And it's very important that these interfacing units are able to process higher power so that the residential customers or commercial customers can make use of it. The issue with string inverters is that we all know, due to partial sharing, because all of these panels are in series, the production is going to be impacted. Optimizers prevent this, but they add cost. You have to have one optimizer per panel. Microinverters are more reliable, efficient, and safe. But the whole idea behind, which works against microinverters, was you need one microinverter per panel. So again, a quick summary of string, micro, and power optimizers each have their own advantage. The best thing about microinverters is that you can install it in areas which require more protection. You can't have high voltage above, let's say, a petrol pump, a gas pump. That's what Indian oil companies are going towards now, but they can't use string inverters because you're connecting these panels in a series connection, and the voltages are just not safe to be operated near a gas pump. So this is where I also work part-time at Spark Systems. We are developing microinverters, high power microinverters. So this is where we came up with the quad concept, where you don't have to have individual units for each solar panel. We have combined these four inputs on the same unit, and you can simply connect it at the back of the panels. We have been able to bring the cost down to, I would say, 12 to 15 cents per watt. We are trying to go down even more. And what I was talking before, grid following, grid forming, there is a requirement now. What if you can have the same inverter do it? We are trying to do that as well. It just adds more requirements on your control, and you don't have much space. The idea is always the same. You have to make things smaller and more efficient. The two always don't go hand in hand. So towards a decentralized grid, as I was saying, so the present grid is following a top-down, centralized, one-directional power flow approach. You have some dispatchable generation going into transmission, distribution, and end customers. But the future grid will be different. You will have a complete multi-directional, multi-source distributed power flow. You might have off-grid renewable energy systems. They are definitely going to increase in the near future. We know that we have heard the demand for these off-grid renewable energy systems in countries like India, in continents like Africa. So this is also going to be, we have to make sure basically that the same inverter can do everything. It can work following the grid, it can make its own grid, and it can work off grid. So to fit so much smartness on the same unit is the next daunting task. And obviously then you might have microgrids and nanogrids, which is, again, as the word suggests, smaller grids. You have to have sharing of electricity, information, and storage will increase. This is a given. Which brings me on to the last slide. What are the challenges and opportunities that we are facing now? The first thing that I said, how do we plan this integrated distributed energy generation? We have to make sure that the irradiance profiles, if it's PV, or the wind profiles for that area is suited enough. Environmental factors need to be considered. Social factors need to be considered. The whole cost of setting up the system. It's not just the device itself. You have cabling cost. You have maintenance issues that you might need to address. So all of these things need to be taken into account. You have to revisit your cybersecurity standards. We are talking so much about there being communication between, let's say, from one house to another, each of which might be its own grid. We have seen that there have been more cyber attacks on US grid operators, and this is just gonna increase. And we need to make sure that there is uniformity within these standards from province to province, state to state. Privacy of user data. We talk so much about electric vehicles acting as a power source, right? But we do know that we use this electric vehicle to travel somewhere. So like no one wants anyone to know where you have been going throughout the day. So these are not the challenges that are associated with power electronics, but these are things that a power electronic designer, a utility operator, everyone has to consider. The grid architecture should be standardized. There is so much variation within the grid codes. I can tell you from experience from a country like India, each state has its own requirements. You can't go above a certain voltage and frequency in one state, and those limits are completely different in the other state. So we need to make sure that this architecture and these standards are more uniform. Transmission transfer limits, they need to be increased, and infrastructure needs to be expanded. It's not just a one-dimensional flow now. It's basically going out in all the directions. It's like a tree with so many multiple branches. Innovation in energy storage battery materials. This is the real bottleneck. If you were to ask me, this is the real bottleneck as of now, which is preventing us from going fully electric. And then again, you have to make sure that you have reliability of when you start electrifying your personal and public fleets, because now you're depending on all of these sources which are intermittent, which are not gonna always be there. So you have to make sure that you do the best you can and you design the system such that you always have the lamp glowing on. These are my references and image sources. I'll be more than happy to take questions and listen to your opinions. Thank you.
Great. Thank you very much, Abhishek. We do have a couple of questions here. One from Brent Pepley. He asks, what is the cost per watt? Oops, moved over here.
Yeah.
What is, oops. Just don't change it because my chat moves when you do. What is the cost per watt for a string inverter configuration in comparison to the micro inverter configuration?
Yeah, so for string inverter right now, the cost per watt, as far as I know, has come down to around 10, 8. It depends on the country. Like we have been dealing with many customers from India, and they say that they're able to get it as low as 8 to 7 cents per watt. But there is always a trade-off. I think these questions, they need to be accompanied with what you are getting. So some inverters, they guarantee 25-year life cycle, which is the same as the life cycle of the PV panels. Some inverters you might get cheaper, but they only guarantee the warranty for, let's say, 5 years, 4 years, or their efficiency drops off. So in the first few years, your efficiency might be higher than the other inverter, but the other inverter will ensure that this efficiency remains the same even after 2 or 3 years. But this first inverter might not do that. It might drop off rapidly. So yeah, definitely string inverter, cabling cost, if you account for all of that, it is cheaper. But if you look at what you are getting in return when you will have the ROI or achieve parity, I still think microinverter will be a better option.
To follow up on that, if you look at maybe the leading edge of this field, the technology, do you see any things that are going to transform the economics of renewable energy?
I would say it
sort of
has to be
technological developments that might be transformational.
I would say so. We have, and it's always been like this. The idea for electric vehicles and all of, they were invented way back in the 80s, 90s. This field is old. The concepts that we are using are not brand new. But one single thing that might change our perspective or make us more comfortable is batteries. It's as simple as that. For the uninitiated, if I start talking about renewable energy, the first thing that they say is, yeah, no, this is not reliable. What if my electric vehicle gets stuck on the highway, or things like that? And that's a completely valid concern. So batteries, smaller battery packs, because if you look at electric vehicles, the majority of their weight is dominated by those battery packs. Smaller battery packs, research into those battery materials. Is it going to be lithium ion still? Are you going towards nickel cadmium? I know people are researching towards sodium. They're using all sorts of researches. So that is the real push that is going to further propel us towards a full penetration of PV renewables.
Great. Let's just check if there's any other. Looks like David Heineman has a question. He's got his hand up on the screen.
Abhishek, thank you very much. That was very, very interesting. And I know, there's a long history between ePower and Spark. What is your take on the pros and cons of doing commercial development coming out of a academic research lab versus, you competing against the Ericssons and the Samsungs and the whoever else might be in this field that's just strictly commercial?
So that's a very that is a very good question. Thank you for the question. It is challenging because the problem, and I'll just be frank, the problem with academicians is that we tend to think a certain way. If you ask a researcher his main priority, it's always going to be, okay, no, I want it more efficient. He's not going to focus on the right problem. So it's more about that mentality which you bring when you're coming from academia and designing a commercial product versus you completely staying, as you said, in a commercial venture. I think it's both good, and I think it's mostly good, to be honest, because we are actually pushing tech. We are actually pushing new things. So we might fail, obviously, because these things haven't been tried and tested. And this is one of the issues that I see, and I don't blame anyone. It's just that the resistance to trying new things, because it takes time. It has taken time for any industry to reach where they are. And whatever works, works. They want reliability. Whereas us, we are always trying to push more. We are always trying to push more tech into our products. So if you have the right guidance, if you have the right industrial experience, combined with proper academic experience, then I think that's the perfect mix. R&D is very important. Until and unless a company invests in R&D, their product is not going to survive long. So it is important.
Good. Thank you.
Thanks. I have another question, but I'm going to check and see if anybody else has a question first. If not, so my question is actually connected to public policy. And one of the things that people talk about is connecting the Ontario electricity grid to the Quebec electricity grid. But I think one of the main differences is that the frequency is different, 60 hertz and 50 hertz. But from a public policy point of view, there are these interties between the two provincial grids, and they're very expensive to build. And because they're very expensive to build, you have to kind of be careful that you've arranged for all your electricity contracts and everything set. And then you can make this like $1 billion investment to build one of these interties. And my question to you is there any simple way of understanding why these interties are so expensive? Or is it just some big thing, there's a lot of concrete or something and metal or something like that? Is there anything special about these interties that make them so expensive? And is it possible that in the future their technology could change, that they suddenly cost a lot less? Sorry, this is maybe not an out of the blue question for you, but I just, since you're in power electronics.
Yeah, so to be honest with you, I haven't thought about this. And this is, like, being new in Canada, I did not even know that Quebec, I thought this was only true for India, where you have two provinces operating at different standards. But and I don't want to take, but if I were to guess, I would say it's because of the devices that they are using. It's simply because of that. And it's the same thing with electric vehicles. You see them being more expensive when there is no demand or incentive. If you provide more incentive, then the costs go down. So no, I don't have a clear answer for that, because I don't exactly know about this intergrid, but that would be my best guess. But I will get back to you. I'll read up on that, and I'll get back to you on that for sure.
Great. So I think we have time for one last question, just in case there is any. I don't see one on the chat. So if not, then I'll just say thank you very much to Abhishek for your talk, and it's very welcome. And we will now go to sector news. So let me just bring up the sectors. Okay, so we'll just go through the sectors one by one. Does anybody have any news about fuel cells? We'll start with fuel cells in honor of Brent Pepley, who's here today. Maybe not. Just go ahead and speak up if you have anything.
Ted, it's Harriet.
Ahead, Harriet.
I don't know if everyone saw that Green Center got some funding. I saw it on LinkedIn. So they got there's an Ontario funding source for innovation, and Green Center got some funding. So that's good for our region.
Okay, great. Transportation, anything in the transportation electric vehicle area? If not, we'll go to solar. Any sector news in the solar energy?
Yes, Ted, I do.
Go ahead.
Helene, hi. Just in the last week, I have read 2 articles in the news that I found saddening, disappointing. that I would like to bring to everyone's attention as issues. They don't affect us directly, but they're of concern. The first was in the New York Times last Tuesday, January 25th. I do have the references to these articles that I will put in the chat as soon as I stop talking. But this one from the New York Times is that there is a fight to rein in growth of rooftop solar in California. And the idea here is that the utility regulators are proposing to slash, greatly reduce the solar panel installation incentives that are currently in place. And this is the growth of rooftop solar and so on that homeowners are doing, a big thing in California, has angered the unions and the utility companies, because every watt that a homeowner produces is a watt that is not supplied by utility or a big wholesaler. And so they want, what's the, I'm looking for the exact chart, what they expect to charge, but sorry, they're not charging, they're simply reducing incentives to the point that people will be disinclined to install rooftop solar. And that one pissed me off. The other one is in the Globe and Mail, Monday, January 31, this past Monday, I believe. Nova Scotia Power CEO says proposed solar fee ensures fairness for all customers. So there in Nova Scotia, they're proposing to impose a fee on rooftop solar homeowners and so on, roughly $8 per kilowatt, amounting to $960 a year for a typical 10 kilowatt installation, which it says here will double the time needed to earn back the cost of installing the system. So again, it's a great disincentive. And here the idea is that the utility thinks that rooftop installations that provide excess energy back to the grid are using the infrastructure of the utility, and that they're not paying their fair share. And so this fee is supposed to cover or to act against the use of the infrastructure by these homeowners and rooftop solar installations. What do we say here? There are customers who generate their own electricity at their home or business and use Nova Scotia Power's power lines and infrastructure to put their excess energy on the grid, or use power from the grid when they don't produce enough themselves. So this is deemed as unfair, and it's thought that everybody who doesn't have rooftop solar is subsidizing the group of people who do. So anyway, enough said. I just want to express my dismay at this kind of attitude on the part of two governments here, one in each country. And so it goes, something to be aware of.
Okay, thank you very much, Celine.
Just jumping in on that. Sorry, Ted. Yeah. I mean, I've seen other states doing the same thing. I guess to my mind, you know, it's a shock to the system right now as we're trying to, you know, get more distributed energy going. But is it the same as, you know, microfit was 82 cents a kilowatt at the beginning, and now it's, I don't know, 10, 15, whatever. Change is going to happen. And, you know, I've been at many a meeting back when I was at Queen's asking who's going to pay to keep the grid stable and pay for these upgrades to allow it to be bi-directional and everything else. So it's yeah, it kicks the individual homeowner, but it is part of a bigger issue. Abhishek, yeah, have you run across this policy issue, and do you have any thoughts too?
Yeah. So this is exactly, I think, what me and Ted were discussing a while ago, and fortunately for us, we haven't run into we have, like, as a company, if I were to say, we haven't run into any such issue yet. But yeah, I did hear this news about governments charging extra taxes or whatnot. They're trying to get more money. So I don't think, and I completely agree with everyone, I don't think that's a good direction to go in. Yeah.
Anyway.
Okay.
Thank you, Ted.
Probably oil companies are behind it for sure.
Probably, I don't know. I don't think you need oil companies. I think the utilities are already enough to. Anyways, let's go on to wind. Anybody have any news in the wind sector that they'd like to share? See if anybody, just go ahead and talk or raise your hand. I'll look out for that. If not, geothermal. I guess there's still that the geothermal building on Princess Street is being worked on. I haven't driven by to see where it is, but I'd love to do a tour someday when it's finished. Water power. Anybody, anything news about water power? We'll go on to bioenergy. And education and training. Certainly, I've been hearing some news that people who are trying to use the incentives to do home renovations, home energy renovations, are running into a problem with lack of energy auditors and other trades, but energy auditors seem to be the bottleneck. Actually, I have a question for the group. If you told me that there was a shortage of energy auditors, I would say, I think there's a lot of energy auditors out there who were trained, 10, 15 years ago, who couldn't get steady employment in that area because the programs came and went. It seems to me that there are trained people out there who could get back into the business and help alleviate this bottleneck. Does anybody have a sense of that?
Well, they have to spend $1,000 to get certified or whatever, Ted. So I think that may be a barrier for some of them. Otherwise, you're right, they 100% qualify.
Yeah.
Yeah, I'm one of Gavin here. Was a certified energy auditor who is going to get back into it, but I've just been waiting for Omicron and Delta to get out of the way, and then Omicron to get out of the way before I start going back into people's homes and doing energy audits.
Okay, well, that's good. I think Rosie has her hand up.
Yeah, I was just curious. This is an education question, not an update exactly, but I'm curious to know. It seems to me that we need to be training a lot of people in all kinds of aspects of electrical engineering, electrical technician. Is there actually a move in that direction? Do we are programs being put in place or increased in capacity? I'm curious.
I think the answer is yes, across all trades, because there's a shortage everywhere. But maybe somebody has more specific information. If not, okay.
Thank you.
Well, let me just go on to the next sector, conservation. If anybody has any news in the conservation area. Certainly the city has City of Kingston has this new program. They've got some funding, I think $15 million to help fund this program where you can do energy retrofits and renovations on your house and have the cost be paid for through your property tax. So it becomes a liability on your house that you can pay off over time on your property tax. And if you sell it, it's very easy because the new owner just assumes that loan on their property tax. So it's a new way of financing.
Is that the way they're doing it through the federal agency, Ted, that Kingston has a pot of 50 million? And
that's
then,
right. 15
yeah.
million. That is that pot of money. So I think Toronto has tried. We had a talk at Switch a few years ago from the person from the organization in Toronto that tried to do this. And the conclusion in Toronto was they couldn't scale up. They couldn't do it on a big scale. So maybe Kingston can do better. We'll see. It's I think sometimes smaller cities are more nimble. So I think Kingston might be able to do better. In case we should certainly tell people to give it a shot. Helene has her hand up.
Yeah, thanks, Ted. Just one of the bees in my bonnet about what you just said, incentives in general. I've long since given up even thinking about any such program in my own case. I find, as a general rule, for anybody who is ahead of the game, anybody who has done the right thing earlier and already has a pretty good house or whatever it is that's being promoted, will never get anywhere. There's no reward for having been on the vanguard. And, it's always pissed me off that these programs that require a before and after snapshot with the work in between to see how much improvement the work has provided. I mean, I get it, but if you're already doing very well, nobody says boo. So I don't know, sorry. Your comment just made me think about that, and it has always been a sore spot for me.
I think there's a lot of people on this call who are in this boat. I mean, I certainly put a lot of things into my house, insulation and so on, that I don't ever expect to.
Every new window I did was because I thought it was the right thing to do. There were no programs at the time. So it's
we are getting the
because they come and go, isn't it?
We're on schedule 14. We are getting the money back from the carbon tax. So I'm glad that my heating bill is not very high.
Yeah, I mean, how does the City of Kingston program interface with the federal program that a lot of us are aligned with to get some refunds on, changing to heat pumps, et cetera, et cetera?
Well, you can use you can certainly use the federal program when you're doing the renos, but you finance it through the city's program. So if you need to borrow money for the upfront costs, you can put it on your property tax, but then you can also get the subsidies from the federal government for if you want to do things. Yeah. Okay. Why don't I just add green building, which is the next sector, if there's anything. Helene, I assume that your hand is not up anymore. Anybody have any news in the green building area?
Hey, Ted, it's Rosie. So a few meetings ago, I gave a little presentation about a process that's ongoing at the Canadian Academy of Engineering, which is to try and develop a roadmap for resilient renewable energy using buildings by 2050 for Canada. So that process has been kind of spread over about 3 years. We've had several symposia to bring in as much information as we can about most recent developments in the field, and we're now at the stage of writing the report, and I was asked to be one of the authors, so I'm working on that.
Great, congratulations.
We'll get you to speak on it later.
I'd love to do that.
If there's not anything else about green building, I'll move on to policy. Anybody have any news in policy?
Ted, I know I'd shared with you, I just wanted to say that I just saw a Pemminar Institute article about, and I'll read the title, "A Clean Energy Credit Registry is a good first step to growing the renewable energy sector in Ontario." And my comment to Ted was, didn't the Conservatives, when they came in, cancel something similar? So I hope this is a step in the right direction. I will certainly look to be following this trading system as it develops, see who gets involved. But that's where, you know, policy will drive an awful lot of what we need to see happen. And this is maybe a baby step from the current government in the right direction.
You know, my impression when I saw that announcement from the Ontario government was, first of all, it was a very early stage thing, like they were looking into it, doing some research. But my second reaction was, this resembles a lot the creation of a voluntary offset system that we started to see, you know, 20 years ago, 15 to 20 years ago. So it just seems like it's going back to something old. Anyways.
But is it better than nothing?
Yeah, it's better than nothing, but there's a lot more that can be done, I think.
Yes.
And let me just say, from the policy point of view, what I can say is that the many organizations in Ontario that are involved in policy are sort of revving up their outreach to the political parties because of the upcoming election. So I think there's a lot of discussion right now between the political parties and different advocacy groups about their platforms and what issues might arise, what things may be on different parties' platforms. So now is a good time for people to speak up and try to be part of the whole public discussion leading up to the June provincial election. Okay, so that is it for sector news. I'll just see if anybody else has any other bits of news.
This is Carol.
Hello, Carol.
Hello, Carol.
And you haven't mentioned the word hydrogen. And in fact, there is a very, 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 very active hydrogen movement throughout the world. We just don't happen to hear much about it in North America. And there is a new hydrogen platform for information, and it's called H2-View. For any of you who are interested in hydrogen. I was particularly interested in this talk because of the potential of inverters to form microgrids. You know, you have your, for example, since you're all supporters of solar and I'm not, simply because the climate's changing and they're very vulnerable and we're in Canada. But anyway, whatever. If you have your solar field and you have your inverters, you can create a little microgrid. Well, translate that into a number of hydrogen fuel cells, and then you can have your little microgrids. And I think eventually we are going to think in terms of hydrogen hubs instead of still a fossil fuel economy. Anyway, I thoroughly enjoyed that talk, and I know there are a whole lot of science problems involved in what my vision of the future is, but I definitely think it's coming. And I will say there is a new hydrogen car or vehicle company called Hyzon, and they're building a huge plant in Australia, apparently. They build great big trucks. Anyway, that's all I'll say, Ted. But don't give up on the hydrogen sector yet.
No. Okay.
Certainly not.
Yeah, sorry for not mentioning hydrogen, but Carol, in the future, when we say fuel cell, please feel free to talk about hydrogen.
Okay.
Well, yeah, I'll remember
But
to mention that explicitly.
there are other things. The hydrogen fuel cell electric vehicle, for example, is apparently some sort of amalgam and becoming more and more popular. But I'm sure your EV people know more about that than I do. That's all.
Okay, thank you. If there's no other sector news things, I will again thank Abhishek for speaking today. And I want to thank all of you for coming here and participating, being part of this discussion. I will leave this Zoom call on for a while. I'll turn off the recording now. Sorry.
Ed, do you want to, are you going to promote the AGM?
Oh, sorry. Yes.
Please,
So
please.
next in March, Switch will be holding its annual general meeting. And I want to encourage everybody, we will be electing several director positions. So I want to encourage everybody to please consider putting your name forward for election to the board of directors of Switch. We'll be sending around an email shortly with a application form that you can fill out to get on the ballot. And we hope that you will join us next month, first Friday of March, for our Switch annual general meeting.
Please join us. We need quorum, which is easier when it's virtual, but still we need quorum. And we need as many engaged and interested people to step forward so we have a robust board and continue to provide a platform and services for the membership. So thank you.
Thank you very much. Yeah, there are several board positions open, so please consider running for the board of Switch. Okay, so I'll just leave this open right now. Thank you for the reminder, David, about the AGM. And I'm going to turn off the live stream, and I'll turn off the recording.